So we will wait for 1 minute. Okay, let this recording to be start. I think it has started now. Okay. Yeah. So screen is visible to everyone, and I'm audible. Last time, I'm audible to you and visible. Give me a thumbs up rapidly. So I welcome you all, and a very good evening to all of you. Hashira, GNV, Lakshdeep, I think JNV Ramnagar, Shiva is there, Senia, Aisha. So I welcome you all in this session of simple harmonic motion. Okay. So in NCRT, you will find the chapter name as oscillation. Okay. But here in the Avanti's curriculum, yeah, good evening, Aisha. How are you? So in Avanti's curriculum, we have the name of this chapter as simple harmonic motion. Okay. So don't worry about the name, although the topics are same that we are going to study. So today we will take an introductory session to simple harmonic motion. Okay. Most of the thing you will understand when we move further in this chapter. So the very simple and very logical chapter is this from whole mechanics. If you will see, if you take up the mechanics, so this will be the chapter that I will select very first because it is very simple and execution based chapter it is. Okay. So without wasting time, we just let's get started with it. Yeah. So have you done this chapter in your regular classes, in your JNV classes? If it is so, just let me know, or you can obviously use the thumbs up. So is this topic covered in your regular classes? Anyone? Yes, I'm listening. So whatever be the answer, we will okay. So we will go through this chapter from basic to advanced. Okay. So firstly, this chapter name is oscillations actually. Okay, got it. Now, so what learning objective in the chapter that we is the periodic motion and oscillating motion. Then simple harmonic motion and uniform circular motion. And why it is so? You will sooner you will get it now because we are studying uniform circular in simple harmonic motion. Because what we are going to do, we will analyze the uniform circular to execute or extract the simple harmonic motion from that motion. Okay, so that is why we are going to focus. We are going to make our focus of uniform circular motion. Then after we are going to do, we are going to do the system exhibiting SHM like the spring system. Okay, double mass system, triple spring, the arrangement of spring. So that we are going to see. After that, damped and solution oscillation. explanation. This is very quick and very short topic. Okay. Is very complex one, but in your syllabus, it is just for your knowledge purpose. Okay. If you pursue your career in physics, the so okay, so I have lost my connection due to the internet connectivity issue. So sorry for that. Okay. So what we are discussing? We are discussing about the periodic motion. Okay. So I have shown you some pictures. Okay. Firstly, this the rotation of our Earth about the sun. Then this person throwing this ball. Okay. Now the moving hand, minute hand of the clock. Okay. Then again this spring going to and fro, and this you are very familiar of. Okay. So now it is clear to you. I have told you that there is an internet connection issue, might be from my side or your side. So that is why this complication has been arisen. So sorry for that. Okay. So is this now clear to you? Yes, yes, obviously. Tell me. So is my voice clear to you? Any issue? Yes. So in this type of motion, one thing we have commonly noticed, from the very first. These objects, these objects repeating their okay. These objects repeating their motion. Okay. So these object motion. Wi-Fi issue. Sorry guys, I'm having a severe internet issue. That is why I'm having this problem. So now I'm audible to you, everyone. Yeah, JNV Ramnagar, you have raised the hand. So now I'm audible to you, everyone, each and everyone. I'm turning off my camera. I think the internet is not proper here, so that is why. So anyone can uh, answer, or you can also give the reaction. Thumbs up. Let me check. Just a second. Okay. But one of the student has said that I'm not audible. Now I'm audible to you. Okay, okay, got it. So I'm continuing this class without turning on the camera. Okay. So you guys must focus on the screen that is presenting in front of you rather than focusing on me. Okay. So what we are discussing today, we are discussing the periodic motion and oscillation. I have shown you several photos of or animations of motion like this one, and also the motion of minute hand of the clock. Okay. So in all these types of motion, what one thing is common is that they are repeating itself. This motion is repeating itself. You can focus on this clock. When it comes to 12 one time, again it is coming back to 12. And this motion continues till the battery of this watch will not discharged. Okay. So these types of motion in which there is a fixed time interval of repeating them is termed as periodic motion. Okay. So that particular motion is termed as periodic motion, in which the motion repeat itself after a fixed time interval. So that particular motion is termed as periodic motion. Everyone got it? What is a periodic motion? Because these are the basic definition of the periodic motions and basic requirement to start this chapter. Okay. So I hope everyone got this. So what is the periodic motion? Periodic motion is the motion that repeats itself after regular interval of time. These types of motion we can also say this is a motion of periodic motion because it is repeating itself after a fixed interval of time. Okay, thank you, Suraya. Very good. So instead of answering, you can just give me the reaction. I have enabled it for you. Okay. Now, these motion is also periodic motion. So firstly, we have understood what a periodic motion is. So these all types of motion that is presenting here, these all types of motion are what? These all are example of periodic motion because each and every motion is repeating itself with a fixed interval of time. After a fixed interval of time. Got it? So that is the basic definition of periodic motion. Now, if we move on to the oscillatory motion, what is oscillatory motion? Oscillatory motion is also a type of periodic motion, but it is not a circular one or any kind of motion. It is only a to and fro kind of motion. Of an object about its mean position. Okay, so that particular motion is termed as oscillatory motion. Got it? I will tell you in this way. Just a second. So periodic motion, if I talk about, the motion, you can take the notes from me. The motion repeats itself after a fixed interval of time. Interval of time. For example, we can consider motion motion of what? Motion of minute hand or hand, second hand. Motion of earth, the sun, etc. Yeah, to and fro motion of an object can also be yeah, good. Any other example is coming up in your mind? Anyone? For periodic motion, that type of motion which can repeat itself after fixed time interval. Anyone? Any guesses? Then we have oscillatory motion. Day and night also the example of periodic motion. So yeah, rotation of Earth is a good example. Oscillating motion, if I talk about it, and so the ending phase of motion is also periodic motion. Very good answer. Is boundary motion and toe and So am I audible to you? Anyone? Okay. I'm having serious, very serious internet breaking issue. So that is why this problem is happening to you guys. I'm really sorry for that. Okay. I'm really sorry guys because this side I'm having a serious internet breakdown issue. So that is why I'm losing the connection again and again. Okay. So where we are on the oscillatory motion. So in oscillatory motion, I have defined it as a to and fro motion. Okay. About its mean position. This motion is a bound motion. It is bounded. This is a bounded motion also. Bounded motion. Okay. Now, if any one of you can guess that oscillatory motion is a periodic motion or not, is it satisfying the condition to be a periodic motion? Now, what is the condition of periodic motion? The condition of periodic motion is that if a motion repeats itself, yeah, very good. If a motion repeat itself after a fixed time interval, that particular motion is termed as oscillate periodic motion. Okay, very good. So this motion, this oscillatory motion is also a to and fro kind of motion, but it is repeating itself after a fixed time interval. So we can say that the oscillatory motion is periodic motion. But but here the problem came. If I consider this motion of sun with earth, this is our earth and this is sun. So the our earth is rotating about the sun. So this motion is a periodic motion because it is repeating its motion. Okay. But is it a to and fro kind of motion? No. Is it a bounded motion? No. So we can say that all oscillatory motion satisfying the condition of to be periodic motion. So all oscillatory motion are periodic motion, but all periodic motion are not the oscillatory motion. Okay, so this is the important term that you would keep in your mind, and some of the student is answering, and this is very good. Okay, so very good student, you are absolutely correct. Yeah, now if we move on, the further we will discuss it. Every oscillatory motion is periodic, but every periodic motion is need not to be oscillatory. Okay, so this is the condition. From the example of this motion, this is the periodic motion but not oscillatory, because here this minute hand is repeating its motion after some of the hours, but it is not fixed to any position, it is not fixed bound to anyone, and this motion is also not a to and fro kind of motion. So this type of motion we can say that this is periodic but not oscillatory. Now, so this you can take the screenshot of this. You will clearly know the difference between oscillatory and periodic motion. Okay. So in oscillatory motion, body moves about a mean position. We have a mean position here. But in periodic motion, there is no need to be the mean position. Okay. The only condition is that motion should repeat itself after some time. Okay. After a fixed interval of time. Now, at extreme position, velocity becomes zero. We will discuss it after some of the time. And in this, velocity never equals to zero. Okay. Okay. And the next point is direction of velocity get reversed at the extreme position. But here, the direction of velocity never reverses itself. It is not happening in any time that our Earth is rotating the sun in counterclockwise direction, and then after some time it changes its motion to clockwise direction. This is not going to happen. Okay, so periodic motion may we have a fixed direction of velocity, but in oscillatory motion we do not have that fixed direction of velocity. Okay, now clear hai sabhi ko? Everyone, is it clear to everyone? You can give me the reaction now. Okay, so now we will discuss. Yeah, of course you will get the previous slide, and let me remove this, so you will take the clear screenshot of that, and let me know when you have done with this. Give me the thumbs up. Okay. Okay. Yeah, you are welcome. Now we will discuss about some key terms, which is period, frequency, and displacement. Okay, for any oscillatory motion. So if we want to discuss some periodic motion or periodic motion and oscillatory motion, so we need to discuss or we need to know what is period of that motion. What does it mean? What is the frequency? Okay. So all these key terms we need to know. Now, if I talk about the period, so you can see the smallest interval of time after the motion is repeating itself. Okay. I have told you in the definition of periodic motion that a motion which repeats itself after a fixed time interval. So that fixed time interval is termed as the period of that motion. That is why this motion is named as periodic motion. Okay. So the smallest interval of time after which the motion is repeated, that is termed as the period of that motion. What is the unit of this motion? It is second. Okay. Now, if I ask you, what is the time period of minute hand? So minute hand is doing periodic motion, na? So after how much time it will repeat itself motion? Tell me. So is it? It is 1 hour. After every hour, after every hour in the clock, this minute hand will be at the same position. Okay. So the time period of minute hand of the watch is 1 hour. Now, if I talk about the time period of second hand, second, second hand. So anyone, any kind of guesses? So Toto is saying that second hand has a period of 1 second. No, no, bacha. In 1 second, it just move this one from here to here. Yeah, now you are correct. The time period of second hand is 1 minute because it repeats its motion after 1 minute. And if I talk about the R end, can anyone tell me what is the time period of R end? Very good, very good, very good, Toto. Very good, Suraya also. So keep it up, guys. It's 12 hour, definitely. You are doing great. Very good. Okay. Now, if I talk about the time period of revolution of Earth, can anyone guess it? Time period of revolution of Earth. 1 year. Okay. Exactly 1 year. Anyone else? Yeah, 1 year has 365 days. I totally understand. But the Earth, if I go in more specific detail, the Earth completes its revolution about the Earth in 365 days and 6 hours. Yeah, approximately you are correct, Suraya. So after every year, this 6 hour add up to this. So after every 4 years, 4 year after, this 6 hour will become 6 into 4, which is 24. So 24 hour means 1 day. So that year has 366 days. Yeah, 366 days, and which is termed as a leap year. Got it? Yeah, very good. You are answering it very good. A 0.242 is not, I think it is not correct, Suraya. But yeah, it has some decimal value, but you can learn it from here, 365 days and 6 hours. Okay. Now we are talking about the frequency. Yeah, got it. Frequency, what is the frequency? Frequency is something, it is derived from the term frequent, which is What is frequent to you? Okay, what is frequent to you? You rise up in the sun rise up, you wake up in the morning. After that, what you will do? You will brush your teeth and do the same thing that you are doing every day. Okay, so the frequency of doing brushes or brushing your teeth, in how much time in a day you will brush your teeth? The most of us will brush our teeth in morning. Okay, so what is the frequency? Frequency is one time only. Okay, some of the student or some of the person will do it two times, one in morning and another in the night. So the frequency for them to brushing the teeth is two. Okay, so here what we are counting how much time this event has been happened in a particular time. So that is frequency. In oscillation, in how many times, how many revolution the object has made, or how many times the motion has been repeated itself in the unit time, that is termed as frequency in oscillation. Got it, everyone? So frequency of the periodic motion is the number of oscillation or repetition occurring per time, per unit time. Okay. Now, if I talk about you very simple example, this is the our this is a watch, and this is the second hand. Okay. So in how much time it is completing its one revolution? Understand my language. In how much time it is completing its one revolution? Completing one revolution in 60 seconds or 1 minute. Got it. If I ask you how many revolution it has covered, how many revolution it has made in 1 second, anyone? How many revolution it has made in 1 second? So it will be in 60 seconds. You can apply the unitary method here. In 60 seconds, number of revolution is 1. This is revolution. So in 1 second, what is the revolution? 1 by 60. Very good. So this is the frequency of this second hand, which means it is completing 1 by 60 revolution in 1 second. That is why it is taking 60 seconds to complete one revolution. Yeah, 1/60th. Very good. Got it? So this is frequency, which means in unit time, how many times in a unit time, how many times that event has been happened. Got it? So the unit is quietly different. The unit is given by SI unit is hertz. Okay. If you have ever heard about the radio in your household and in any shop, so in that radio, there are different channels, and that channels are mentioned in hertz, 100 megahertz. Okay. 93.5 red FM. So this 93.5 is nothing but the frequency, 93.5 megahertz. This is the frequency of that radio wave which is coming to that radio. Got it? Now, so this unit is named after a very reputed person in physics, which is Rudolf Hertz. So it is named after that. The reciprocal of the time period is 1 by t. So you can say that frequency is denoted by this term. It is termed as nu. You can say it nu. Okay. So nu is 1 by t. Remember this formula. And we have also seen it by the unitary method. In 60 seconds, one revolution. So in 1 second, 1 by 60. So you can also say it in t second, there is one revolution. So for 1 second, there are 1 by t revolution. 1 by t revolution. And this is nothing but the frequency. Got it? So this is very important formula. Nu is equals to 1 by t. Now, these all things we have covered. So time period for minute hand is 1 hour, which is 3600 seconds. Frequency is just inverse of it. You can also note one of the unit. Unit is also termed as a second inverse. Second inverse or per second. This is also the unit of frequency. So frequency say what you have to keep in your mind that it is the number of revolution or number of times that event has been occurred in unit time. And here what is this event? Event is the revolution. Okay. So in how much time, how many revolution that particular object had made in that unit time is termed as frequency. You can note it down here. So 1 hertz is also equals to 1 cycle per second or 1 second inverse. Now, this is the question in front of you guys. A human heartbeat at beats at around 72 times in a minute. This is the normal BP, normal heart rate or pulse rate, 72 times in a minute. Now calculate its frequency and period. So try to solve it. So we can do it by unitary method also. In 60 seconds, it is beating with 72 times. Okay, 72 beats you will hear. So in 1 second, if I able to calculate what is the beat rate in 1 second, which is 72 by 60, you can cancel it out. Again, so 2 6 are 12, 2 5 are 10. So we can say 6 by 5 times. No, frequency 2. I don't think so. Anyone getting the answer 2? I think this should be the answer, na? Okay. So 5 by 6 will become 1.2. Koi baat nahi, it's all right. Everyone made mistake. So 1.2 time is the frequency of it, because this much value of revolution our heart made in 1 second. So we also know that nu is nothing but 1 cycle per second. So it is 1.2 revolution made in second. So frequency here, I can write it like this. Frequency here is 1.2 hertz. Yeah, very good. So yeah, we can also say that it is 1.2 hertz, because 1 upon second is also 1 hertz. Okay. Now what about the time period? So time period is nothing but 1 upon nu, 1 upon 1.2. So it is 10 by 1 by 2. Got it? So this, you can say it is 5 by 6. So time period is 5 by 6 second. Which means, now clearly understand the thing. Completing one revolution or one beat, it will take 5 by 6 seconds. So that is the time period. But in 1 second, it will beat 1.2 times, 1.2 hertz. That is the frequency. Yeah, very good, Ashira. You have got it. So anyone, any kind of doubt in this question? If you have any kind of doubt, you can ask right now. Okay, so I think the lecture has been over, and I'm so sorry for the disturbance during the lecture that you have made, that I have made for you, and it's totally my fault because there is an internet blockage. So, but I will take responsibility of that. So I'm so sorry for that. It will not happen again in the next class. So we will discuss the things what we have left or what we want to cover in the next classes. Okay. So thank you so much, guys, for being attentive in this lecture. Yeah, very thank you so much, because these types of, after having these types of brokerage in internet, breaking of voice, you guys are maintained with me. That is really appreciable. Yeah. So I appreciate your patience. Thank you so much, guys, for being attentive. Take care of yourself. Bye bye.